PM, everyone, and welcome to another workshop for the Infinite Space Bazaar. My name is Josh from Celestia Labs, and I'll be your host today. Today, I'm excited to welcome Jordan Oroshiba from the Astria team. Jordan is the CTO there, and we'll be learning about local rollup development with Astria's shared sequencer network today. Jordan, we're glad to have you here, and we're excited to learn more. How
Yeah,
are you?
GM, thanks for having me here.
What is Astria?
Yeah, Astria is we started by calling it kind of a shared sequencer network, which is technically accurate in a sense. I think a better way to think about it is that we're building a sequencing layer on top of Celestia for people to utilize and kind of make it easier to get fast finality and decentralized sequencing of the roles they're building.
Awesome. So this kind of solves the centralized sequencing problem that exists basically on every rollup today, right?
Yeah, that's the idea here. It also offers, for rollups building on top of it, and this is kind of using our tooling and developing with it. The idea here is to offer a really easy to use developer experience. So if you're building a rollup, whether that's something that's an EVM, it's something novel, or a Cosmos chain, the idea is that you can use this for any of those. It can provide a platform to do maybe more you know, novel ideas. We had the messenger rollup thing that we put out.
Yeah.
It was kind of a hackathon project that we did, and it's entirely not built on top of an EVM, just built straight out of on top of the services and whatnot we've built as an exercise to test it out, trying to make a great developer experience for people building on top of it. And yeah.
Looking forward to learning more. You want to go ahead and we're going to do a demo first?
Yeah. I'll start with walking through kind of the tooling and the demo, and then kind of explain what's happening underneath the hood here. Yeah, I can go ahead and all set here for demo.
Awesome.
All right, are we presenting?
Oh, yeah, we're up. Sorry.
All right, cool. So I'm going to walk through some of the docs that we have here, just around the CLI tool we've put together recently, and this is kind of, we've had a couple of different CLI tools that we've played around with, and this is kind of our next phase of learning. The first thing we've done is really about deploying the deployment tooling. And what we've built now is more geared towards the developer and kind of their needs when building new rollups. And so trying to build this entire pipeline of tooling from I'm building my rollup to I want to go forward and then actually deploy it and have a production application. And how do we make it easy to do that full cycle? So to get started here, I actually set up and cleared and uninstalled everything. So I'm gonna actually go ahead and install here. There's directions here for binaries. I'm gonna use this. We're gonna work on updating the docs so that it points to different OSs. This is by default gonna work for just Mac Silicon. All right, let's completely empty demo environment here. All right, and now let's paste that. Gonna download everything. Just gonna follow piece by piece through here what we have, so we can see what you can expect to see if you run it on your local machine, and then we should be able to see the version on this. Go ahead and then we'll go ahead and this require I do a sudo command on it. I move this just so that I don't have to type the / through everything else in the demo.
Sudo mv.
Yeah, thanks. What do I get for not copying and pasting?
It's okay. It might be better that way.
Great. And then, this is just basic software stuff. We can add package management stuff and whatnot to this over time. We can see that we have the same version running there. We also have instructions here on how you can build from source. This GitHub repo is open source, so you're free to go and look at it. I can run us through doing this, but it takes a little time, and you just have to have go, and then we use just for commands as opposed to like a make file. It's a little bit cleaner for us. So once we have that, this is going to be the CLI tooling we can use for interacting. This has both the ability to work with remote to talk to our sequencer via CLI commands. We'll do a little bit of that later through the demo here, as well as tooling for spinning up and running things. The other thing I'm gonna pull here is I'm going to actually download a rollup we've built that's built on top of this. We have a fork of Go Ethereum, and we're gonna get started. The first step here in getting everything set up is to actually go and let's go in here. We're just gonna download this fork of Geth that we've modified. This works cleanly on top of all the other services and whatnot we're gonna be running to get this going. All right. And then we're check out our local dev branch. This has kind of the tooling and whatnot. We'll be merging this in the near future. And then we're just gonna build the Go environment that we have here.
And just as like make, right?
Yeah, just is very similar to make. It's built in Rust. It offers, a simple way to scripts that you're using very frequently to create kind of nice, almost like building a custom CLI for your given repo. Yeah, again, very similar to make, just a little bit more customizable in terms of, well, maybe not more customizable, but easier to customize in terms of what you do. At least from my viewpoint.
Yeah.
All right, so we've built this rollup. We're now going to go ahead and do some configuration for what's needed in order to launch this. I'm going to start by just creating a new wallet address here. This is going to print out a private key, obviously. This is going up on the internet. No one should use this in real life. And then I'm going to edit this Genesis file that we have. And this is going to have information, has a couple of things in it. One is that, it's just it is a adaptation of like a normal Geth Genesis file. There's also some additional configuration features here for using the rollup. All right, I'm gonna just delete this whole string here and replace it with this new address. What this is going to do is that, I now know the private key of on spin up or spinning up a dev rollup here. This is going to allow us to know the private key that we can use when interacting with that in order to submit transactions and do such things. All right. So we have that there. I'm also just going to export this private key so I don't have to scroll up later. All right. We have that all set up. We can use that for our test transactions later. And now I'm going to actually just start this again. We have some start commands here that make this a little bit easier. Just init this and set up our, I think I have to, yeah, I just have to delete the sun. All right. Initialize the Geth node, and then I'm gonna leave this running here. That first thing I do is start up. There's nothing connecting to this. There's nothing that's gonna happen with it. And then I can create a new tab here. Let me make sure I have this big enough for us.
We did get a shout out for kudos for the character size. So yes, thank you.
All right. Hopefully that's big enough. Cool. And then let's cd into our demo directory and create it here. All right, cool. So now we have this all started up. There's some commands that you can do here to restart this. We'll go through kind of the flow there and how that might work for you a little bit later. Next thing we have within our actual CLI tooling, we have some tooling in order to run a whole Astria stack locally on your machine where you can see all of the logs. I'm going to start by just cleaning in case I have some stuff there. And then we just do Astria go dev init and create some configuration files. It's also going to pull all of the binaries for various components that we need down. And depending on the version of, these binaries are built for, they are built for either Apple Silicon, Mac, or Intel Silicon, as well as Linux on, a x86 architecture. And when you go and you pull the correct one, it'll pull the correct binaries for everything else that you're running onto your machine to run.
Nice.
All right, and then we are going to go ahead and start this up. All right. So as we spit up here, we're going to see we have the core sequencer, we have a comet BFT, and then we have two components called composer and conductor. We have an in-flight thing here. Usually on first startup, this conductor errors. With this tooling, you can go and you can enter, you can see logs, and then you can go back. And then this one, you can just press R and it will restart the selected component. So this is going to be, if I had this bigger, you would see a little bit more in terms of what's going on. So I'm going to just go ahead and disable auto scroll and then wrap so we can see kind of that because it's so long, it seems like that goes up to the top. Oops, I haven't done with the text that big. But what we're seeing here is that we will let's see. There we go. We can see new blocks being created and proposed, executing index block events.
Like every second or 2 seconds?
Yeah, sorry, I'll go a little bit slower.
Oh no, but the blocks are being created about every few seconds, it looks like.
Yeah, that should be created every 2 seconds. I actually think we have, as always, everything fails at the most inopportune time. I'm gonna go ahead and right here we can quit, and then I'm gonna again go do a Astria go clean. Net run. All right. Finalizing commit of block. All right, I think we're good here. If we go and we switch back over to our tab here, we can see we can clean up these logs a little bit, but you can see there's various we're getting get Genesis info, updating of commitment states, and blocks being executed. If we go in here where I was saying, I'll show you real quick what you can do here is when this is, so because I restarted the whole network, what we can do is we can do a just clean restart. And that will spin everything up with a fresh database. In here, every time you restart, you usually have to restart the conductor process because it connects into that. That's part of why we start that up, something we're working on to improve. And we can see here that we have commitment states, and there will be blocks and such which are getting executed as well as new blocks are created on the network. Cool. So that's getting everything running. We now have a blockchain. We can go do some interaction with it. We have some docs kind of further down in here on how we can send a whole bundle of transactions to it. I'm going to create another new tab here. Make this larger. Sorry.
You're good. While you're at it, actually, can you move the little StreamYard is streaming bubble because it's over maybe
yeah,
to the top.
that's
yeah.
There we go. Cool.
You
And
restarted
then
the
I'm gonna
container back there with just like hitting R in the TUI.
Yeah, you just hit R in the TUI when you highlight over it. You can press enter, and you can see things are being sent to it. You can see the execute block again. If I make this a little bit wider, we'll be able to see a little
Nice.
bit more of kind of the logs here. Larger screen, smaller font, you'll be able to see a lot more. um, and we can see, we can go and we can look at the sequencer, and we can look at what we call composer. So real quick on this is probably a good time. This is the quick overview of how we go through here. I give a higher level overview of kind of what these component boxes are and how we
Mhm.
envision that working, and then also what your dev flow here is. So when I go through here and I was like, okay, I want to go and I want to make changes, right? What I could do here is I can exit out of my geth node. I can go make changes to my rollup, do whatever I want to do, and then I can run. In this instance, just clean restart. But basically, I clear out the database and I
Mhm.
restart this node. I go over here, I can keep this running in the background. All I have to do is restart my conductor. What we actually see here where that ran through everything is that because the sequencer's been running, this is going to sync all of the blocks that have been created. So if you're like, oh, I have this edit and you change something with a smart contract, execution isn't working, you go, you make some updates, whatever you do. Um, you can go and you can just restart this. It'll replay the execution that wasn't working for you. Um, and in that roll up that you've already set up. So all you have to do
Nice.
is go your kind of dev iteration cycle. So in comparison to the previous tooling that we've had to put together, it was really easy to run a roll up. But in order to do this active development cycle where I go, I edit, and I get my changes updated into it, could be more tedious.
Yeah.
Um, so the other thing here that you can do is, if you have a set of transactions that you're running and you like having inside, this comment BFT data is persisted. So if I close all of this down and start back up, those transactions will continue to persist. We're
So
working on ways such that you can say, hey, I have this sample set of transactions I run through. You can go and you can do a test. You can query. You can say, given everything else at block height, 100, I should expect to see this data hash, and you can see that every time. So a lot more useful for kind of the development cycle, as opposed to before we were using Kubernetes and Helm charts and all of that, which is really great deployment tooling once you've
yeah.
already got your software figured out. So in terms of the actual architecture of what you go through here, I have a presentation that I can kind of go through, which will talk a little bit about the way we think about this, the high level of, I can talk about what is a composer, what is a conductor, purposely obtuse names, and how they exist in our system.
For sure.
Oh, there we go.
I have it up.
Cool.
Yeah.
Sweet. So the idea here, like shared sequencing, I say that it's a sequencing layer, and that it's really built around. I like to say that shared sequencing is a blockchain which is optimized for base rollups, where you know Justin Drake had this in his initial post about based rollups. It's based if it's L1 rollup is said to be based, or L1 sequence when its sequencing is driven by the base L1. I'm not a huge fan of the L1, L2, L3 terminology myself. I'm a bit of a modular maxi, and I and come from a microservices background. So I think that what we can actually say here is uh, that a rollup is said to be based when its sequencing is derived from the base blockchain. Um, and what defines L1 your base, it can be a little bit you know uh, hand wavy. In Ethereum it's very clear, but I think in this modular space where we use Celestia's DA, you have a sequencer, you have your own rollup. From our perspective, the sequencing kind of defines the canonical data state, but then you have your own state transition function and all of that. There can be social consensus over the software that's being run. It's not as simple as there's like an L1 and it's the source of truth. Um, and so this is kind of, when you say like a shared sequencing or a sequence, what makes it shared is that many people use it, but the idea of this kind of sequencing layer is people can take their transactions, they end up getting submitted down. We end up with this large block of everything, all the transactions from all the various rollups, and then offer the tooling in order to take these rollup transactions, turn those into rollup blocks, and these go through your rollup, your state transition function, if you will, and then create state routes on the other end, while utilizing we post our data to Celestia from the sequencing layer. Can talk about exactly how that's all architected, but the idea of kind of the conductor and the composer tooling is that you don't have to worry exactly about how it's structured and where it goes to. It just works. Celestia provides better data availability guarantees, which allows us at a sequencing layer to consider more about how we make the sequencing optimal, while you get this firm propagation censorship resistance from Celestia underneath it. So in terms of what this architecture actually looks like, the composure here, when we have the full setup, is that we have our sequencer application, which is, when we go back and we look at everything we have running, it says sequencer, that says comma BFT. Comma BFT is the consensus algorithm we use, and the consensus engine. The sequencer app here is built in Rust. It's a custom ABCI application. Is a relaying component in order to post the data to Celestia that reads off of this comma BFT network. And then you have what's all composed into the rollup. And we have what we've called the conductor and the composer. And the rollup is your execution state machine box. It's the app. If you're writing things in a Cosmos app, that would be a rollup. If you're writing, working in Ethereum land, like the execution engine would be the part that we're calling the rollup. This is really just the straight transition function and block storage. The conductor is kind of the slightly magic sauce. It's not really all that magic, but it abstracts away a lot of the technical difficulty for you. It knows how to read off of sequencer. It knows how to read off of Celestia. There's some configuration that's determined based off of your however you do your genesis on your rollup. That's when we looked at the Geth genesis, and there's some extra fields there. That's all configuration for how the conductor is going to run. That's hard coded into your genesis file. It's going to read blocks that we call soft commitments off of the sequencer and execute them as quickly as it receives them. That's at approximately 2-second block times right now. And then it's going to read data off of Celestia and then update to the rollup state, like, hey, there's now a firm commitment to this state. If for whatever reason your connection to sequencer gets censored, it's fully capable of reading data off of Celestia. In the future, it will also, there is a need to have access to headers. We don't have this integrated yet, but adding a light client basically into here, so it becomes a light client sequencer network, required for doing verification of the data posted to Celestia. And then composer tooling here is kind of the submission flow. If you're building a rollup, the cost of running your network, or you have the L1, L2 fee profit situation. This is basically a way to take transactions as they come in and push them down to the sequencer when they are ready. We have built into this kind of two ways in order to submit transactions. One of them is that if you're running like a Geth EVM, it can monitor the mempool on the EVM, take pending transactions. It does some wrapping and submission directly to sequencer. This is a nice user experience for the users. There's nothing technically stopping a user from creating their own transaction, wrapping it in the sequencer transaction, and submitting it directly. So you do have this direct submission path into the sequencer as well, kind of similar to escape hatches when you're using other rollups in the Ethereum ecosystem. So this is the core of what that is. And then when we talk about actually what you're building here, that I think the really curious thing here is we talk about we have the rollup, and then we have conductor, and it's like, what is this interface and how is that driven? Because that's the part that makes this conductor aspect actually really generic for building different blockchains. We've integrated thus far, we've built our own custom messenger rollup. We have a test integration with Cosmos SDK, integrating actually directly into Rollkit, which then integrates into the Cosmos SDK. And then we have this Geth integration and being able to kind of bridge and execute things across all these kind of unique ways that you're building things. So in building this interface, we took a look at kind of a lot of prior art. This is pulled out of Arbitrum's Nitro white paper. And it's if you squint,
Sorry.
yeah, no worries. If you squint at this, it looks a lot like a sequencer layer. Transactions go into a sequencer for Arbitrum, and then they get a sequencer feed, a soft guarantee that goes down, gets batched and compressed and pushed to the L1 chain. This is very similar to what our relayer does. Is it takes these batched and compressed things and pushes them to the sequencing layer. Take a set of sequence transactions, put them through the state transition function. We get direct into the sequence transactions. The state transition function can also read the batches off of the L1 if it doesn't have access to the sequencer directly. You generate your L2 blocks. One of the things that we don't have any strong opinions on within our stack here is what you do in terms of this like settlement, where you post your L2 blocks. If you're building on top of Astria, it's wholly deterministic how you get there. It's just a matter of figuring out what the right state root is and how you agree on that state root. So the other art we have here, this is pulled straight out of Optimism's docs. This is how they drive execution of their rollup using the engine API. There's a couple of problems with this from our perspective. When you're looking like, oh, can we reuse an existing API? I'm not a huge fan of the way that this API is designed around legacy get Ethereum stuff. But the engine fork choice updated here, it updates what your canonical head is. It also can initiate block building that happens within the rollup node. That's something that you already have a deterministic set of transactions coming out of the Astria sequencer, so you don't really need to do this initiate block production. There's this whole payload ID, and then in order to actually execute the block, you need to submit an already built Ethereum block and then update to that fork choice state. Not really great from the perspective of generic nature. It works for Ethereum, obviously, but we wanted to build something that's not highly tied to a specific block shape. The other prior art, and one we actually use within our sequencing stack, is that there's ABCI, and this may be small for folks. Sorry if it is. But there's a lot of things that go on in ABCI, and a lot of them don't really apply when you're doing a based rollup. The idea of an entire consensus round and having to do votes and all of this, your transaction set is already set. It's just a matter of executing it and getting your state proof. And there's also stuff in terms of state sync and all of that, which is kind of again to the point of no opinions on how you settle your state roots. Not something that we're really wanting to implement and push forward with a strong opinion. So if we were to use the ABCI, we could more or less remove 2/3 of it. You have to initialize your chain still. You need an ability to get info about the state of the chain. Finalize block can just execute, and then you need to have the ability to do commits to it. And so we were like, what if we had a much simpler API? That this is essentially how our API works. There's a whole sequence diagram up on our specs doc and a doc that I'll share later. But the core of this is that we do this execute block and we get a new rollup block. And then we also have this idea of updating soft commitment states with this idea of the soft and firm. There's the soft, which comes from the sequencer, and then there's the firm, which comes from finding that data posted in Celestia. One thing to note here is that when we say it's soft, because we're using Comet BFT as consensus, there has been a whole consensus algorithm run over this. There is consensus over the data, and it's been agreed upon by a decentralized network. What we're really saying by saying it's soft is that we can't guarantee that everyone had access to the data because we provide data availability to our proposer nodes, but you as an individual may struggle to get the data. Using Celestia node and having access to data availability sampling allows you to kind of enforce, hey, there's a lot better guarantees of data availability and keeping you from getting censored from receiving information. So what does execute block look like? So we've built this as a gRPC service, such that depending on any language you want to build on top of, you can go implement a server implementation of this. Very generic, whether most blockchain folks are working in either Go or Rust. We use both. We've integrated with Go Ethereum. Conductor itself is written in Rust, and we have a couple of different implementations. The core here is that when you request, you have to know the block you're executing on top of. You have to know a set of transactions. This is data pulled out of the sequencer. And then in order to ensure repeatability, you need to have a timestamp. And this timestamp is taken straight from the sequencer block itself. And it also ensures, this is one of the really nice things about using a shared sequencer, is that you have this kind of shared wall clock time. If you utilize it as your fork choice rule, there's options we could get into of like, well, I really want to do blocks every 20 seconds and I consume 10. You can, but you lose some interoperability by doing that, because you can't guarantee that every other rollup that's using that sequencing layer has blocks at the same time. So if I do something, within the sequencing layer, you can submit a bundle that says I'm submitting transactions to 5 different rollups. I sign it, I push it down. We can have that run, and it will only run on all 5 at the same time. You have to know if your rollup is actually going to execute on that block time. This is kind of, I think, the best way to move forward. And then you respond with what a block is. And this is only the things needed to continue driving this. See, there's a lot of other state roots and all of that, and information presumably in your block, but just validating that the timestamp was correct based off of what was sent. Parent block hash, so we know what to execute. Validating that you executed it on top of the right block. The hash of that block, so we know what to execute on top of next. And block number just makes it a lot easier to index and keep on top of that. And so this is all the information that we need, and allows us to do state commitments and whatnot after that. And again, this allows, because there's no determination of what block shape is, any of that, it's very simple. And even in comparison to this, where we eliminate things, when you're using ABCI, if we look at how finalized block works, or how in here you do prepare a proposal and all of that, but those are all highly tied to relying that you have to use the Comet BFT header shape. You can have whatever header shape, whatever block shape you want here. You just have to be able to return these fields, which we think are pretty generic across blockchains.
Seems like it. Is it number,
yeah.
hash, and parent block hash for the block.
Yeah.
I would
Yeah.
say.
Number, hashes, and times. The blocks happen at a time. They have to have a hash, and they're numbered. So that's the core we have here. We have some more information. I'll go through some of this here as well. If we go back to doing the screen share, I can go a little bit over
for sure,
showing where we have some of these docs and some of the information on them. Cool. Are we sharing again?
Yeah, we're up.
Cool. I'm gonna go ahead and just make this a little bit wider for us right now. Okay, so a couple things here. Just I'm gonna have to make all of these bigger as we go through. So
Perfect.
this is our Go Ethereum fork right now. We're in the process of, this is a strict fork of Go Ethereum. We're in the process of migrating to a different branch here. We'll deprecate and point to that when it's updated. That will be kept in sync on a kind of more similar to the way that OPGeth is. This started as us just confirming that everything we built worked, and then over time it's built into a lot more. But this can be interesting to go and look and see. Within here we have, I mentioned that we have this server. That was interesting. We've added this gRPC execution server, and this is a implementation of that interface. There's some validation, and these are kind of all of the 8 endpoints that you have to integrate in order to support that API. This is also documented within our specs of our main, we have a monorepo from all the code that's not our core CLI. And this is gonna spec out, similar to if you've read like engine API documentation and whatnot, what each endpoint is. There's a sequence diagram at the end so you can understand what's going on, but implementation details of what certain conditions that need to be met, as well as publishing all of the gRPC stuff to Buff, so anyone can pull this down and build on top of it, build server stubs in many different programming languages, and there's documentation on each request and whatnot. The core of the actual execution service that you have to implement here is just these 6 methods, where 3 of them are very simple, and is executing your block and then updating and tracking your commitment states. And so just wanted to kind of point out those 2 pieces of documentation. If we flow through here, we can see in this sequence diagram what exactly happens from a developer perspective across all of the stack. As a rollup developer, you only really have to be concerned with how this transaction, what you have to interface with on the rollup node. But this can be interesting to look at if you're curious about what happens with my block after I submit it to the sequencer, what happens in terms of consensus, how does it get pushed and to the underlying DA and batched, and when am I going to get my commitment updates. Kind of interesting thing to look at. And then also wanted to show kind of, we have this messenger rollup, and I said previously, this is another implementation of our actual execution API on top of this. Similar structure here, but this is the whole server that's required in order to drive and start integrating with that, and provides a neat little on-chain functionality where all of that data ends up getting posted to Celestia, visible for everyone there, as well as on our sequencer network. Yeah, that's all the pages and such that I had, and just kind of wanted to be able to show people existed. This also offers another way. The messenger rollup currently has like a Docker Compose thing that you could use as a sample of how, if you like using a Docker flow, how you could utilize that.
What is the messenger rollup? Um,
Oh yeah, this is our messenger rollup running on top of our latest devnet. You can go to 8bit.chat, and anyone can type things in here, and hit send. It's going to give you a unique ID per reload of the page. So I can type in a couple of things here, and people can go to this website and type and publish. Yeah. And this is all posted to the sequencer, and then yeah, built by Astria / underneath. All this data goes to the sequencer before getting executed on the chat, and is posted to Celestia. It's not necessarily human readable on Celestia. We're using like Brotli compression right now on the data that we push down in order to preserve data space and use as little as possible. But over time, we'll provide some more information there so that people know where their data is stored, what the format is, and how they can interpret it. Try to add some tooling on top of that.
so what I want to understand a little bit, like more at a high level, what happens
Yeah.
if I send a chat here? So I hit
Yep.
send. Where does my message go? Like, where does it actually get posted to Celestia? What does it do when it's
Yeah.
going through the shared sequencing layer?
Yep. So in terms of the messages that we send here, these are all getting posted to our. I don't remember. We have 2 DevNet networks that are live right now. I don't know whether or not this one is live on the Dusk 3 network or the Dusk 4 network.
All good. Implementation details.
But implementation. If I was thinking, if it's the 4 network, I could actually go show you in a block explorer where the data is and whatnot. We have a similar to how Selenium works. There is a Astro Trek that has been built, and you can see blobs and rollup data that have been posted. It looks like, since we've been using this, it's probably the Dusk 3 network. But you can see rollup transactions and blocks as they flow through here. So what happens when we post the data through this 8-bit chat is that as a developer, if you're building on top of this, we can see this. What's first going to happen is it reads this data, and then it's going to forward it. I actually think there's two implementations, one that directly wraps and signs them and submits them to sequencer. There's a new version which we're in the process of upgrading, which uses the composer. It kind of functions as a wallet mechanism for this. When you're using this chat and it's free to post, ultimately someone's paying for the posting, right? So it goes through this composer piece, which wraps that data, sends it down to the sequencer. It goes into the sequencer mempool, goes through the full ABCI process, prepare proposal, process proposal, execute, come up BFT happens. That happens on a 2-second block time. The conductor is following these blocks, and then reads off of the sequencer every time there's a new block height.
Mhm.
It reads the data unique to its own rollup. So there's actually an API that we've added to our app here, which allows you to get the data that's its header data off of the sequencer, as well as the filtered data unique to your rollup.
Okay.
And then it does validation over that data because we're pulling a partial block. We have a couple of state roots and all of that, we have a couple of Merkle trees that are constructed in order to do validation when you're pulling the partial data. It does the validation of that, and then it sends it over. First, it's going to do the execute block that's sent over, so the block gets executed, and then we update the commitment state to say this is safe data. The idea of this execute block and then update safe is that also as a developer, if you're running your thing, you can run manual commands and you can say, I want to execute this and just see what happens and test out just the execution before you figure it out. Finalization, how you're going to store the data. You're just like, I want to see what happens if I execute this one piece of data. You can do all of that. And then it's going to go here.
Is that after the
While this is
firm or soft commitment? Like when does it actually end up?
this will show up as soon as it's a soft commitment. And so while this is happening, because the sequencer runs on this 2-second block time, / approximately 11-second block times, there is a relayer component that we run. Post that data to /. It's going to batch all of the blocks that have occurred over that time together, and it's going to post. There's going to be a blob for the sequencer kind of header metadata that's needed for verification. And then it's going to use what we call a rollup ID. It's similar to a Celestia namespace, although ours are a little bit different constructed. We derive the Celestia namespace from the rollup ID. And we post the data to that namespace. So when you go in Conductor again, and that's reading data off of Celestia, it's reading that sequencer metadata and your unique block data without having to pull anyone else's. So you can see all of your unique sets of transactions. You can see all of those on your specific rollup namespace on Celestia as well.
Actually, do you have this one handy?
I do not
okay.
have this
Yeah,
one.
okay.
Yeah, sorry. That would be neat if we could go and show you what all is being posted there. We also have, so in this instance, you'll note that like when I'm running everything here and I'm running locally, we are not running a Celestia instance locally while testing this. That's from that there are ways, and we can go through here that actually one thing I didn't do in this demo is there's also a way when we're doing this to run your rollup. Like, oh, I tested it all locally and it works. Within the overview documentation here, you go down. It's like, okay, I tested it all locally. I actually want to test this against DevNet, right? Instead of running a local sequencer and comment BFT, I want to run this against DevNet. We have documentation here on how you can do this, improving the workflow here a little bit over time, so that you don't have to go manually edit as many files, add some more configuration stuff. You need to, the downside to posting your data to DevNet is that like you need to have kind of dev tokens, right? So there's a faucet that you can go to and grab tokens there and use, but it's a lot easier for most development to have your local flow and then to do a test verification against the DevNet.
Garang Patel asks in the chat, who pays for the chat posts? They're free, but someone's paying for it, right?
Yeah, right now that's us.
Okay.
We run this, and this is all running right now. The way this is running, this isn't live on mainnet, so um, this is going through our our DevNet. So it's
Yeah.
kind of our free funny money.
And I guess it's going to a Celestia testnet as well.
Yeah, it's going to a Celestia testnet as well.
Nice.
In a production setting, for the chat here, there's options. So for the EVM, kind of the way the flow here works is that when you post data to the sequencer, it collects enough fees in order to pay the DA costs underneath it. And then similarly, when you're designing your rollup, again, this is up to your rollup design, to your design and what you're doing. One of the upsides of building on top of an EVM is that there's a wide set of wallet technology and whatnot available. But you could build this such that you go and you hit send and it asks MetaMask, and then you pay whatever, a couple cents, low gas fees because it's your rollup, and then it goes through and signs a transaction, sends it. You could honor just some basic ETH stuff while not having to use the whole EVM, and just gather enough in fees in order to also pay for various data posting things.
Okay.
Or you could have this such that it takes the transaction, wraps it, and signs it, and sends it directly through to the sequencer without having to touch your rollup node beforehand. Those are both options.
And then another question from Going is, who would pay for it in a realistic scenario? What do you think?
Well, that's going to depend on your business.
Yeah.
Real, you know, um, and what you're trying to accomplish with your rollup. I mean, it could be a a user ends up paying it. It could be that um,
The roll up itself.
there's the roll up itself pays for it because this offers value in some other way to them back through other things. Maybe through this you update this modular chat and you can do swap trading through it, and there's ways that you make fees off of that. There's various, like, you add bot integrations and all those sorts of things. Maybe that's how you make money, and it's worth it for people to just be able to send nonsense through for free because it gets people using your product. Ultimately, business decision.
Yeah. So I guess like you also could think of it as kind of like in the EVM world, there's a lot of account abstraction tools, and one of them would be like a
Yep.
paymaster. So I think you can kind of think of this implementation as like Astria is the paymaster. They're just covering,
Yep.
subsidizing the fees for everyone. Um, yeah.
Yeah, precisely.
So I have a few questions, unless you had anything else.
I don't have anything else. Happy to take some questions.
Yeah. So I guess you mentioned Nitro and OP Stack during the presentation,
Yeah.
and you also mentioned Rollkit. So
Yeah.
my understanding correct that you could use like all of these on their own, obviously, but like I could have three rollups running, one with each framework, and they could all use Astria's shared sequencing layer without like really like any problems. Like it would just work, right?
Yeah, yeah. So I mean, so in terms of this local dev environment, this isn't optimized in order to show that. But back in um, the last kind of demo I did with all of this was using a, like, has a lot more dependencies, not as great for local development, but shows kind of what you can do in terms of deployment. I was able to deploy 4 different, Geffen rollups on top of different namespaces with different chain IDs, and you can connect to them, and there's no interference. They just run smoothly next to each other. Same thing with any of these other stacks. We have like a cursory go through of getting the OP stack to work on top of what we have here. Um, the I think the OP stack is in a lot of ways very similar, except that it has opinions on where state roots get posted. From how this works, the conductor piece looks a lot like what OP node is in their stack in terms of OP node is responsible for reading and verifying and driving execution. Very similar to a consensus client on traditional Ethereum, and very similar to what Comet BFT does in Cosmos chains. But yeah, you could run all three of those on top of a sequencer, and because of the way all the data is namespaced, no interaction between them required whatsoever. The other cool thing, and this is something that we'll be investigating more in the future, is because it's all posted to different namespaces, you could theoretically have a rollup you post and you say, what I'm actually interested in is parts of data from both of these, and I'm going to observe all three of these rollups data they're posting, and then do some action based off of the conglomerate.
Interesting. Sound like a meta rollup.
Yeah, you could create something like a meta rollup. I think this is more useful if, as we build up over time, you could have a rollup that posts, Oracle data or something along those lines, and
Mhm.
that could be consumed across many different rollups as its
Interesting.
own Oracle data set
And that kind
at the
of,
same time on
yeah,
all of the rollups.
it sounds like it would solve the Oracle problem for rollups if there were one.
Kind of, yeah. Yeah.
Yeah. Growing has another question. Actually, first, a thank you for the last answers. And apologies if you've covered this already, but are there any optimizations made now or planned in the future for posting data to Celestia, i.e., batching or compressing?
Yeah, so the data we post to Celestia is batched and compressed. So we batch across, because we have block times of 2 seconds and Celestia's 11-second block times, we batch all of that data together. And then we compress it with one of actually the nice things, if we talk about the way Arbitrum works, they have their sequencers very much in the hot path. So they do compression using I think it's like Brotli at like its lowest setting to compress data and post it. Because it's actually not in the hot path of you getting the data back from the rollup, because we operate on this 11-second time window, we can actually do a little bit more compression. And so I think right now we added Brotli at like a level 5, which gets you in large data cases. So in instances where you have larger amounts of data, it can get up to like a compression ratio of 8, so eight times as much data as you would need. Saves money for rollup developers, keeps our fees lower,
Yeah,
and yeah.
that's cool. When Astria Reth, go on.
When
Sorry.
Astria Ref.
Yeah.
Yeah, so this is something we've investigated going back to our core team. The sequencer, composer, and conductor are all written in Rust. The very earliest design docs of Astria from before Ref was announced had us using REVM, and potentially putting getting a EVM running that was kind of a full custom thing on top of this. Um, the answer is just like it's a matter of staffing and stability, building all of the integrations in. Um, at one point, we were halfway done, and they changed their database, so we just haven't prioritized it
That's
recently.
okay.
But yeah, eventually.
You were going on something before I asked that.
Oh, I was gonna say too that the other aspect here when we talk about who's paying for the fees, right? We compress the data that we post to Celestia because Astria has no insight into what you're trying. I mean, we have the bytes, but we don't do anything with them except keep them as bytes. If you were doing this sort of pay master flow, and your rollup wanted to, you could theoretically do compression on the transactions themselves before you read them, which can save fees at higher up the stack as well. Obviously, reduces the effectiveness of the compression for us lower down, but it's a way for you to reduce your fees as well.
What kind of scale does that reduce, like the size by?
Yeah, so this is where it's going to depend on the type of transactions you have. Compression is only going to be useful on larger data sets. So, if you were a rollup that was building something that for whatever reason sent, large globs of strings through, like you might want to compress your data before you push it. Um, but if you're doing smaller, EVM transactions, and thus it's probably not going to be as beneficial because
Yeah,
until you get to larger batch sizes, the compression doesn't offer much benefits.
makes sense. What bounties do you have for the Infinite Space Bazaar? And the follow up there is, what would you like to see built?
What would I like to see built? Okay. I believe for the Infinite Space Bazaar, we have a like best non EVM rollup. This comes down to I the EVM exists and is very popular for a lot of reasons, but I'm really excited to see the innovation that people can do when there's other tooling options. And it's one of the things I'm excited about personally in the long run about this sort of infrastructure is that it unlocks me from having to build Cosmos or not. I can build whatever I want. Um, so we have that bounty, and I think I I I don't want to miss say the dollar
Abs-
amount here, but that's what we have a bounty for if I recall correctly. Um, what would I like to see built? I I don't think I have any like really super strong thoughts here. I think there's things that could be interesting in public goods standpoints. I think the messenger rollup we put together started as just a meme
yeah,
that we had within our team because I was saying that like everything eventually becomes a everything eventually becomes. Are we still presenting? Or are we just talking? We're just
I'm
talking.
going
Okay.
back. Oh,
Um,
whoops.
oh no, no, I wasn't. I didn't mean to present. Yeah. Um, the everything eventually becomes a chat app is something that's said in a lot in like Web 2 circles of every app that you build eventually someone integrates chat with it. And so I was like, we're building a blockchain. We should build a chat app because everything eventually becomes a chat app. Um, and then we did it as kind of a team hackathon project. So I think whatever cool thing you're doing is and whatever like interests you is really cool. Um, but one of the ideas I've had floating around the back of my mind is that it would be really cool to have audit logs that are posted on a blockchain, some sort of rollup specifically built for this. I in a previous life I worked in privacy and compliance data stuff. And so the ability to say, this person accessed this data and we know it's true. One of the big things when you're working at a big tech
Interesting.
company or some sort of small companies who has access to the databases of the audit logs, because if you're an actor within that that's doing something fraudulent, then you may be able to go and delete the log of your audit. So by having sort of audit logs on this public ledger, it costs money, but it provides this functionality to a company, even if you're not building on top of Web3 technology, to be able to say we posted the data onto the blockchain, it's there forever, so we can guarantee the audit, and it's publicly hosted, public good. I think it's a cool idea.
Interesting. One more question on compression. I think anything other than compression, posting during low gas, etc., or is that not really relevant right now?
Um,
I understand the question.
yeah, so yeah, I think I understand the question. As the EVM Dencon upgrade went live, we saw some price spiking on like blobs within the EVM space. We haven't seen that as far as I'm aware of on Celestia to date. There was a brief period of high gas fees because people did inscription with actual transfer transactions as opposed
Yeah,
to using blobs, which is really
yeah,
funny to me. But we don't have anything around prioritizing low gas periods or anything with data posting. There's not a direct in our current system, it is a non-automatic update on the sequencer side in terms of fees to update around things. There's a toggle where you can be like, okay, the fees need to go up. Um, but yeah, so nothing around that. I think long term there's some like derivative market stuff over blob space, but the reality in Celestia right now is when I look at the blob space is that it's not being overutilized at the
Yeah.
moment, so we're not seeing any huge gas fluctuations. As we get around that, we'll figure out the way to prioritize that. If you prioritize for gas fees, there can be downsides, right? Like I'm going to post data only when there's low gas fees. It's like, well, I think that right now the gas fee's high, but the next block it ends up higher. How long do you wait before you bite the bullet and just say, I got to spend
Yeah.
the money?
Yeah.
So without some sort of smoothing function abilities to buy groups of blocks and whatnot, that'll be kind of probably the future there.
Cool. Speaking of the future, are there any things that you're really excited about that Astria is working on that you might have not shared already?
Mm. Um, I'm really excited. I mean, not something that's not shared, but excited to see the Forma stuff that we've been working with them to get the NFT space on top of Celestial Live. We're in a place right now where we're working towards. We have a slightly different architecture to the way that most blockchains and are operating in terms of what quantifies as a dev net, what quantifies as a test net, and what qualifies as a main net, maybe not as a main net. I think we all have a pretty firm agreement on that one. But so we've launched we've done these dev nets,
Mhm.
but haven't launched a test net to date. And that's because of my view on a test net is that a test net, you have to have decentralized folks running things. If you have a bunch of test nets with no incentive for the people running them, it can be difficult from a validator relationship. um, but the other aspect is I think test nets are really intended as to be as close to possible as what mainnet will be. And so we're getting really close to feeling like we're locked into a point where we're ready to launch testnet, do some testing of the network decentralization pieces there. We've done internal testing on this, um, but haven't you know gone out and worked with all the validators and getting everything running. That they're running some full nodes right now,
Exciting.
but yeah, that's exciting for that.
Awesome. And where's the best place to go if I'm building something with Astria? I run into something I have a question about. Is the ISB Discord a good place?
Yeah. The ISB Discord, we have four of us in there. If you're working on Infinite Space Bazaar stuff, great place to go. We also have our own Discord with like an issues ticket management thing if you're running into issues, or you can open up a GitHub issue on um, one of our repos if you have something more specific to a specific code base.
Cool. And I guess a good
All of
place.
our
Yeah.
Yeah, this is one of the things that from day one, all of our code has been open source, so it's out there and available for you to look through and read.
Cool. And I just want to throw the website out there. Astria.org is where you can find all of these places that Jordan just mentioned. I want to thank everyone for attending the last workshop of the week, and we look forward to seeing you next week for another one. Jordan, thank you for teaching us about Astria and yeah, showing us a demo as well. That was really insightful.
Yeah, thanks so much.
Have a good one, everyone.